Section 3.2 is called quadratic functions, but you'll also be solving for cubics as well as quadratics. The two things we're interested in here are x-intercepts and zeros. And you're going to use the zero factor property to find them. And all the zero factor property says is if we have a bunch of factors, in this case 2, if either one of them is 0, we have a solution to this problem. So all we have to do to solve this equation is set each of these equal to 0 individually and get our solutions. Okay, the solution to this is negative 3/5, and the solution to this one is 7/6. Now, the long way to go about this is to set them equal to 0. Then move the 3 over, and then divide by 5. Which gives you your negative 3/5. And then do the same thing with this one. But an easier way to do these, if you have linear factors, and by linear factors I just mean exponents of 1 on these variables, is just to change the sign on this and divide by this. Change the sign on this, divide by this, and you get your answers. So the zeros for this one are negative 3/5 and 7/6. And the x-intercepts are negative 3/5 0 and 7/6 0. Same information, just in a slightly different form. Usually, however, you're going to have to do the factoring yourself. So here's a fairly easy one. So I'm looking for two factors of 8 with opposite signs that add up to negative 7, and those would be minus 8 and positive 1. So the zeros would just be negative 1 and positive 8. Let's try a harder one. Okay, here we have a cubic, and the numbers don't look so good. Well, let's see what we can do with this one. First thing we want to do is pull out common factors, and I can pull an x out. Which gives me this. Now I just have to factor 7x squared minus 34x minus 5. And we have a couple of methods to do this. The first one is the trial and error method. In other words, take the factors of 7 and the factors of 5 and try and mix and match them so I get a middle term of negative 34. And that can get confusing when the numbers get larger. We can also plug it straight into the quadratic formula, and that works, but it's kind of long. The other way to do it is turn it into a factoring by grouping problem. So let's do that off to the side. So there's the equation I want to factor. What I'm going to do is multiply the first and the last terms, and I get a negative 35. So what I'm looking for are two factors of 35, opposite signs because of the negative, that add up to negative 34. And they would be negative 35 and positive 1. So what I'm going to do now is replace this negative 34 with negative 35 and positive 1. So that's still my 34. I've just rewritten it a bit. And the reason I've done that is because now I have 4 terms and it's a factoring by grouping problem. So in this set of two terms, I can pull out a 7x. That leaves me with x minus 5. Nothing I can pull out of here. And now I have a term of x minus 5 in common, so I can pull that out. And I'm left with 7x plus 1. So now I can replace this with this. And now I can find my zeros. Let's see, so I have a 0 at 0, 1 at 5, and 1 at negative 1 over 7. And I'm done. And now let's try a slightly harder one. Now, we can't use the zero factor property unless we have a 0 over here. So if you see a problem like this, the first thing you want to do is rewrite it like this, so we have a 0 on the other side. And the second thing to do is to try and factor it. So I'm looking for two factors of 6 with the same sign that add up to negative 1, and I can't find any. So if you can't find anything to if you can't find any factors, automatically plug it into the quadratic formula. So let's do that. And let's simplify this. So that's 1 minus 24. And when I simplify that some more, I get that. And the only simplification we can do on this particular one is pulling that negative out from under the radical as an I. So the basic procedure, make sure it's set equal to 0, try and factor. If it doesn't factor, plug it into the quadratic formula. Alright, here's one that we can solve in a couple of different ways. First thing we want to do is try and reduce this as much as possible. So let's divide both sides by 2. In other words, we'll divide this by 2, and this by 2. So we get x squared minus 13 equals 0. Now we have two ways to solve it. Actually, three ways. And the method you use is entirely up to you. The first way is just to factor this. We have a square here, a minus, and if we allowed ourselves to factor using radicals, we'd have a perfect square here too. So we could just factor this as x minus radical 13 times x plus radical 13 equals 0. And I'd have zeros of radical 13 and negative radical 13. The other way I can do this is to move the 13 over and take the square root of each side. which gets rid of the square on the x, but whenever I do that and remove a square using a radical, this side breaks into two parts, a positive part and the negative part. And again, I get plus or minus radical 13. The third way, of course, is the quadratic formula. Let's try one more kind of like this. Almost the same form as before, and I can divide out the 4 to make it a little bit easier. So I'll divide this by 4, this by 4, and this by 4. And again, if you really don't like either of the methods I'm going to show you, you can plug this straight into the quadratic formula. Here the a is 1, the b is 0, and the c is 3. But let's try the factoring method first. For the factoring method, I need a negative in here. So I'm just going to turn that positive into a negative. And I'm allowed to do that as long as I multiply this by negative 1 in order to not change the equation. And if you recall, I squared is negative 1. So I'm allowed to change this sign as long as I tack an I squared onto the 3. And now we have two squares, and I can just factor. So I get an answer of 3i and negative 3i. If I'm going to extract roots, I move the 3 over to the other side, take the square root, which gets rid of this square, but since I've gotten rid of that square, I have a positive part and a negative part. Excuse me, those should be radical 3's. I have a positive part and a negative part. And all I have to do now is bring that negative out as an I. So we get exactly the same answer either way. And again, if you hate both of these methods, just plug this straight into the quadratic formula and you'll get the right answer.